Thank you very much. It's great to be here with this group. I don't have a lot of interaction with the PMI members, but I'm very familiar with a lot of the work and some of the certifications. I really appreciate the opportunity to be with you today on this happy Cinco de Mayo day. And I'm going to share a little bit with Lean and Six Sigma, give you some ideas for how you can use these concepts. Again, my name is Jane Tierney. I am the founder of Purple Link. It's a supply chain consulting company. I founded it in 2015 to help companies look for the waste and the risk in their supply chain and to find the dollars that are leaking through that supply chain and draining the bottom line. I work with clients and give them tools and techniques, some of them Lean and Six Sigma, to help them remove the waste and reduce the cost and then sustain those savings year over year, because it's very important to organizations that once you get the cost out, to keep it out and not get that cost creep that we're all familiar with that tends to happen sometimes. So tonight we're going to talk about Lean and Six Sigma. I thought I'd start with this. This may be a little bit fuzzy. If so, I apologize, but I'll read it to you. It says on the left panel, I just read this great book about how to lean our business processes. And then in the middle, it says, everybody's doing it. We'd better jump under the bandwagon before the train leaves the station. I'm putting you in charge. And then the final panel says, if you need any management support, you know where to go, with our friend Dilbert grumbling and grumbling and grumbling. So some of you are maybe familiar with that. If maybe I could see some hands or just some nods of people who have Lean and Six Sigma in their workplace, have worked with these techniques before. Few of you. Good. Good. I'm going to give you kind of a high level overview of some things and talk about that. I'd like to make this interactive. I know it's hard to do on Zoom, and I know you guys are probably tired from working all day and probably being on Zoom quite a bit, but I encourage you to turn on your cameras, to ask me questions, offer insights on your experiences as well. So
you can use a computer.
I'm sorry? You might want to mute yourselves. I can mute everybody if that makes it easier. But feel free to unmute yourself and ask a question or offer insights, as I said. So we're going to talk about a few things today. The first thing is, what are Lean and Six Sigma really, and why bother with all the other initiatives and all the other challenges that companies have with COVID? Why would we stop and go try to do something else like Lean or Six Sigma? Because there's plenty to do, there's plenty of opportunity, and there's lots of ways. So we're going to talk about why bother with that. I'm going to start with 5 S's and look at some of the Lean concepts, because I think that's the easiest place to start. And I also encourage all my clients and all the companies that I work with to offer Lean ideas and to look for those and try to incorporate those as much as possible. They're usually inexpensive to incorporate, and there's a lot of good return on the investment, the limited investment it requires to do that. These are easy things to learn as well. We're going to talk about some Six Sigma aspects and everything, and then talk about some of the things to measure. And then finally, I'm going to do a raffle and give away some prizes. So it's part of what I always like to do. So we're going to cover quite a bit today. I want you to stay connected, and I want to make sure I award the prizes at the end. The only way I have to do that is for you to send me an email. You can send it to jane@purplelink.co, and all you need to do is put in the subject line webinar to get into the prize drawing, but you have to be here at the end to win. So if you get bored and leave early, then you can't win the prize. So if you'd like to participate in that, please send me an email to jane@purplelink.co. There's no M there. Just put webinar in the subject line, and then you'll be in the drawing. But don't worry, if you don't want to do it now, I'll give you another chance at the end before I actually start drawing names. So why bother with Lean and Six Sigma? Companies need and want improvements. They all need that. They want that. They talk about that a lot. And now, since we're a year into this pandemic, there's even more pressure on those of us that work in corporate America to try to find ways to improve processes, procedures, and most of all, improve the overall results, because people want to see results in their companies. So that old phrase of faster, better, cheaper certainly still applies. They want faster time to market, faster product development, faster time to upgrade and implement the changes. Then they want better quality. They want better flexibility, better agility. Those are words we've heard throughout the pandemic and will continue to hear. Better responsiveness, customer satisfaction. And then they ask for better return on investment, return on assets, better financial performance overall, and including things like inventory turns. And they ask for all of these at lower prices with less direct, indirect, and implementation costs. So they want everything cheaper, but they want it a lot elevated before, but compared to what we've had before. So it's that continuous pressure to do better, faster, cheaper. There's a lot of drive to make these changes, and there's a lot of ways that lean can help with that. We're going to talk about simplifying processes, looking at the speeds to make things quicker, improving the flows to make them easier, and this nice flow of material through that supply chain. We're going to talk about minimizing inventories, and we're going to look at some error proofing and some other techniques. So there's a myriad of reasons that you probably all are here tonight. And James introduced the idea of getting your credit for the webinar. And that's always a paramount thing for anybody who has certifications. And if you need that certification, you need that credit for attending the webinar. So that's one reason. But these concepts are pretty familiar. There are a lot of talk about Lean and Six Sigma, but I'm sometimes surprised at how little people really know or how familiar they are with these actual concepts and tools. These are very broad topics, and they're deep, and there's lots of courses that you can take. There's whole university courses. There's lots of certifications that you can get, and we'll talk about those in a little bit. But there's a myriad of ways to apply these. I'm going to hit you with some highlights tonight, and I'm going to hopefully pique your interest so that encourages you to learn a little bit more and start trying these out for yourself. And in order to do that, I'm going to start with a little history and some basics. Lean and Six Sigma were heavily derived from the Toyota production system, in particular Lean. The Toyota production system was developed, just as you might think, by Toyota to help improve their production, improve their productivity, their efficiency, reduce their costs. And Taiichi Ohno, who's one of the founders of the Toyota production system, one of the architects, if you will, he said, all we're trying to do is to shorten the timeline from order receipt to collecting cash for the goods or services that are provided. So it seems like a simple thing to do. And there are so many ways to do that. But the Toyota production system evolved by looking at lots of different ways, finding a consistent manner, consistent process to apply so that you can actually achieve the results and reduce the things you want to reduce and improve the things you want to improve. So Lean is really about eliminating waste. It has a heavy reliance on the subject matter experts, the people that do the job, the people that are closest to the job. So you can't implement Lean unless you're going to get everyone in your organization involved, because it really does rely on the people that are actually in the weeds and doing those jobs every day. Lean looks at taking time out from processes, reducing the time it takes to complete processes. It looks at taking waste out of material so that you don't have to pay for as much, that you can save money in the material. They look at taking the waste out of the flow through of the material and of the services that are provided so that you can eliminate waste from those and improve the bottom line. Six Sigma is a lot more about reducing variation. It is pretty heavy on statistics. Six Sigma is done within a process. You find out what you're going to measure, what you want to control, measure that, control that, make your tweaks. And there's a very specific process that they use, and we're going to go through that tonight as well. Six Sigma is about reducing the defects overall and actually reducing the categories of defects. And they rely heavily on the Pareto principle to understand which defects are the most prevalent, most common, and start there. Don't start with just anywhere. Go very much from what the biggest challenge is, the biggest problem, and then work your way down. And Six Sigma by definition means 3.4 defects per million opportunities. This is where a lot of people get hung up. They say, we don't do a million of anything. But statistically, what you would have if you have Six Sigma quality is 3.4 defects per those million opportunities. So we're going to start with lean. Lean is all about finding and removing the waste. So there's a lot of Japanese words that are used in lean. And here's a little cheat sheet for you. Because comes heavily from the Toyota production system, they relied heavily on some of the Japanese terms that are used. So I'm just going to go through these pretty quickly, but these are things that you might want to learn it and be familiar with. Some of them you probably are familiar with, some of them you may not be. So the first one is the one thing that lean is attacking, and that is muda, which is waste. And that again comes in all forms. It's time, it's material, it's space, it's anything that you can think of it that is not essential to what you're doing. In this last year, we've had that word essential designated for people. This is essential work, so you have to come into the office, you have to be here, we have to keep running, we have to keep our factory up and running and at full speed ahead. So that essential work, that essentially is what lean is trying to do, is to take the waste out. So muda is waste. A Kaizen means change for good. It also means continuous improvement. And it's also a word often associated with activities involved in lean, which are very short, intense, focus on areas to make improvements. These Kaizen activities don't usually last more than a day. Sometimes they're just a couple of hours. They don't cost a lot of money because there's not a lot of time to spend there, but they may make some recommendations on things to buy, tools to buy, or shelving to buy, something to make the area better or make the process better. So it may result in a little bit of cost, but it's not a highly high investment area. So Kaizens have a couple of different words, but one of the main uses of the word Kaizen is for continuous improvement, which is what Lean and Six Sigma are all about, is to make improvements and then to continue that process, treating this as not a sprint, but a marathon, to keep at it and keep going. Kanbans are visual signals. They're often cards, laminated cards, or tags that are used on the factory floor or in inventory. Poka-yoke, it means to error-proof. A couple examples of this are the fact that if you have a car and you have people sitting on the seats, but somebody doesn't have their seatbelt on, you'll hear that ding, ding, ding that tells you that, or maybe the car door is open. And then my other favorite is the ATM machine. So if you go to the ATM machine, you put in your card, you punch in your number, tell it how much cash you want out. And sometimes you can just grab the cash and go and leave your card behind. It's not as often that you grab the card and leave the cash behind, but different machines have different ways. They either give you, again, a bell, an audio signal that says your card is still in, or the one that's closest to my home that I use, it won't give me my card. It won't give me my money until I take my card out of the slot. So I put my card in, do my thing, ask for the money, and then I have to take my card out before it will give me the money. And that's an error proofing thing. So it's virtually impossible for me to take my money and walk away without my card, because I have to take the card out of the machine before it dispenses the money. So that's error proofing. Muri is to overburden, and that applies to people and machines. So not only do people get worn out, but machines get worn out or maintenance gets put off. I know some of you probably relate to, well, you know, those tires really need to be replaced, but I'm going to wait another month, or I'm going to wait maybe 2 months until I can save a little money or take it out of another area here. Maybe I'd like to get my car oil changed every 3,000 miles, 5,000 miles, but maybe I might push it to 6,000. So if you overburden things, machines or people, that's Muri. Mura is inconsistency. And that's one of the things that is abhorrent to the Lean and Six Sigma philosophies. Their whole premise is that things will be done in a consistent manner. It will be very, very consistent and repeatable. Probably you all have either eat on some occasional basis or maybe have eaten in the past at McDonald's and eaten a hamburger, right? Maybe see some nods or whatever. You don't eat at McDonald's because it's the best hamburger that you can buy, do you? It's not all that great. It's not something to write home about. If you want to talk about French fries, you might get a little different perspective, but their hamburgers are not that great. So why do people eat at McDonald's? Anybody?
Efficiency. They're really fast and they're good at, your experience is always the same. You go to McDonald's in Las Vegas, you'll have the same tasting burger that you get in LA.
Right. Thank you, James. It's very consistent. It's quick, it's efficient, so you know what you're going to get. You're not surprised. You're not surprised that it's full of pickles or it has onions or this or that or the other, because as you said, the burger that you buy here in Los Angeles is going to taste the same as the one you buy in New York or Atlanta, and oftentimes around the world, because they have those. Now they do a few little nuances in different ones around the world, but for the most part, it's pretty much the same. So you don't eat there because it's great. You eat there because it's efficient and because it's consistent. So consistency is one of the tenets of Lean and Six Sigma. Gemba means actual place. And the way it's often used is with a Gemba walk, which is really a walk through the factory, a walk through the work area. It's walking, actually being in that actual place where the work is being done. So it's not management by walking around so much, but it is akin to that. But it means you're actually looking at things from a firsthand perspective. You're not just taking somebody's word for it. You're going out and checking that and walking around and seeing what's changing. So you want to look and see if you have consistency in the workplace. You want to look for things, anomalies, things that maybe aren't consistent, and where you can put some consistency in there, put some order in there. And that's a Gemba walk. Kata is a form or the order of doing things. And it really is referencing adherence to the processes that are in place. So it talks about the order and the process, but it really also goes further to say, are you doing what you're supposed to do? Oftentimes you'll see that there are processes created. And then in the olden days of manufacturing, you used to see process manuals and a lot of work instructions and things like that. And you see documented processes that this is how this flows. Now, most of that, thankfully, in most workplaces it's electronic, but I'm always surprised at how seldom people actually reference those. So somebody went to a lot of time and effort to actually document a process, but if you don't read it and don't adhere to that, then it's really not doing its job. So this kata is really ensuring that not only do you have the process to help the consistency, but people are actually doing what they're supposed to do in the order they're supposed to do it. Then Genshi Genbutsu, and my Japanese pronunciation is horrible, so I apologize to anybody for butchering this beautiful language, but that means go see for yourself. Again, it's akin to the Gemba walk, but it means don't just take a lot of hearsay, don't just take the things that people tell you, but actually go check it out. And then finally, Obaya refers to a large room. And really, this is about getting people together for broad discussions. It's akin to a war room. And it's really saying that making a safe space where people can bring up issues and say, hey, this isn't working right, or I saw a problem with this. It is not playing a blame game, but it's really highlighting things. And it's making that safe space, even if it's not physical space, if it's making it a workplace where people are encouraged to speak up about things that are not right, that are not working, raising their hand when they need help, getting something identified when it goes wrong very quickly so that it can get addressed and get fixed. So those are some good Japanese terms to know, and hopefully your pronunciation is going to be a little better than mine. So the thing we start with oftentimes with lean is the 5 S's. And these are 5 Japanese words, again, 5 Japanese words, but we've chosen words in English that really represent the same thing. So, and the idea is that you do these in order. And again, the premise is to get rid of the waste. And one of the things they're trying to do is to eliminate clutter. The idea is to Marie Kondo it, if you know Marie Kondo and the life-changing magic of cleaning up and cleaning out. First, eliminate the clutter, remove the non-essential items, look at the things that should be used occasionally, and you want to store those nearby, but they don't necessarily have to be out in the open, not on the workstation. And typically this is applied to workstations, but these are good things to apply to your home office, to your closets, to your kitchen, any place where you actually do work. Now that we're moving outside and starting to do barbecuing and things, this is a good area for that. Anything that you do, that any type of work that you do at home, as well as the work that you do in your business. So get rid of the clutter, get rid of the non-essential things, and think about what you need occasionally. Make sure they're accessible, but they don't have to be as out and as prominent as the things that you use all the time. So once the clutter is gone, and that's called sort. Once the clutter is gone, we're going to do some straightening. We're going to set things in order. This is about those things that you said are essential. We're going to make sure they have a place, a proper place. And this is where you might outline those. And you see workstations that have this, the lines around where the scissors go, and there's other tools, and that's where that sits. Or maybe there's a label down on that says this is where the carton of screws go, or the fasteners go, the bolts. So any of those kinds of things. And it's back to what your mother and your grandmother probably told you, is there's a place for everything, and make sure everything's in its place. So it's really straighten and then set in order so that you have some kind of order to that. Next, you want to really make sure that you clean the area. This is sweep and shine. So it's including the floors, including the walls, including the tools, the machines, any of the equipment. So it's really making this new is what you're trying to do. Make the space nearly new. And the reason that you do this, one, because it's easier and more motivational to work in a clean space, but it's also done to highlight any nonconformities and make things more obvious that don't belong there. So if you think about cleaning all the floors and there's an oil spill, you're going to notice that right away. If you don't have very clean floors and there's some dirty things and whatever, you might not notice that. So you're going to look for things that don't belong there, as well as having a nicer place, a nicer environment to work in. The fourth step is standardization. And this is one that really helps everything stick and makes sure that things aren't difficult to follow. If you have a very elaborate and complex order of where to put things, you're not going to follow that. So it needs to be this keep it simple, stupid kind of thing. So but you want to standardize that and make sure that everyone can follow the same pattern. And then you want to expand it. If it works in one workstation, will it work in another? If it works in one product line, can you apply it to another? This is kind of a lessons learned thing. And in project management, it says this is what you learn from project to project. So the things that you identify that work, you want to put into other projects and processes other project managers can use and on other projects that you can use. And things that don't work, you want to document that as well. So you standardize things as much as possible and transfer that knowledge to wherever you can transfer the knowledge. Finally, you want to sustain. So if it works once, that's great. But if it works 5, 10 times and you can keep that process going, that's what you really need. Something that is now becomes your standard operating process. So you want to make sure that you have vigilant application of all of these principles, and that starts to create this culture of continuous improvement. Now, some businesses lately I've seen add a 6th S, and they add that for safety. I don't know that there's a Japanese word for it, or if that Japanese word might start with an S, but safety is a very important area in all factories. My background is as an industrial engineer, and so I worked in a lot of factories. And then when I got into supply chain, I worked with a lot of suppliers and their factories. So safety is paramount, and it's something I always look for when I tour a factory. So some argue that safety is built into these other steps about sorting, straightening, sweeping, shining, standardizing, and sustaining. Others say that you can't put enough emphasis on safety. So whether you choose to add that or not is up to you. You can use the 5 S's and add the 6th one if it makes sense, or make sure that it's incorporated in the other elements. There's some values of lean too that are important. One of the things that lean is based on is saying, get out of your own functional silo and really look at things from different perspectives. And it's not only looking at it from different perspectives, but from internal, but external to your company. So they say, put yourself in the customer's eyes, put yourself in that customer perspective. Use tools like voice of the customer, change hats, so to speak, and try to step back and look at things that your customer might be seeing and not just what you see from internal to your company. I've seen companies that say, well, you know, this is the best for us, and so we're going to do this, and we're confident our customers will love it. Well, they might and they might not, and they may come back and ask for changes that might make your life a little less easy to do if they have significant changes. So it's best to ask them upfront, keep them involved, and keep that perspective in mind. Along with looking at it from a customer perspective, they also say to become the patient. And that means you're going to walk through the value stream, and we'll talk about that in a minute. Look at what happened before, what happens next, really evaluate that process and walk through every step of it. So if you have a documented process, you want to know, is that what's being used? Is that what people are doing? And is that a good process? One way to do that is to try it out and actually do it yourself. Until you do it yourself or have different people do it to get their perspectives, you're not really sure that that may be an optimal process. Then they add to the M's. When I'm an industrial engineer by trade, and I learned that you look at man, material, machines, and methods. Those are the things that you look at: people, equipment, the processes you use, and then the materials that are involved. But that's expanded here. They include not only those 4 things, but add in measurements and the metrics you're using, because Albert Einstein, who's one of my idols, I really am fascinated by him and admire him. He said, not everything that can be measured matters, and not everything that matters can be measured. So metrics can be really good, or they can be a little bit deceiving, and you can use different things. Use metrics in different ways. So you want to look at, what are you measuring? How are you measuring it? And is everyone, all of the stakeholders, are they measuring it the same way? One of the good examples that I use on that is on-time delivery. I work a lot in supply chain, and that's one of the things, and everybody's looking for on-time delivery. And there are lots of ways to measure delivery, like full orders, complete orders, and things like that. But when you measure on-time delivery, are you measuring when it hits the dock? Are you measuring the date the transaction happened? Are you going back to your supplier and looking at the day it was shipped? So if I'm a supplier, I'm probably looking at the day I shipped it, or it was picked up at my dock to say, I did my job. So that's what I'm doing. But there's a lot that can happen between the time it leaves the supplier's dock and the time it gets to the customer's dock. So if you have multimodal transportation like we do these days, where you have things that get on a ship out of Asia and then they hit the dock, the port of Long Beach or Los Angeles, which you probably know has been backed up, and there's a lot of boats sitting off the shore trying to get in and get unloaded. So that's been taking longer. And then it might have to go from there to a rail car to get shipped across the country to Chicago or New York. Then it gets unloaded at the rail station, and then it gets put on a truck to go wherever it's going. So you've got all of these different things. So which one are you looking at? Which transportation node, which transaction, and then who is responsible for doing that? So the supplier could say, hey, it left my dock, maybe my dock in Thailand, it left my dock when it should have to be at your place by this date. Maybe that was 5 or 6 weeks, but all these other things have happened, and now it's 8 weeks and you still don't have the product. So do you hold the supplier accountable for that? Because it didn't hit my dock, that's the date I measure when it hits my dock. Or do you say, ask the supplier, what did you do? So if you're not measuring it the same way, measuring it from the same type of transaction, you're not going to get the same result. So that's important. And then they add in the E for environment. So this is another area to look at where you want to make sure that you're looking at the whole environment, you're looking at the different aspects and how that is fitting into your company or your project. And then one of the other values that Lean espouses heavily is cross-functional teams. Not only internal stakeholders, but anyone who's involved. So that they very much espouse bringing in customers, bringing in your suppliers, working cross-functionally with all of the different stakeholders to make sure that you get the best result that you can for your organization. So they really emphasize cross-functional teams, and cross-training is another big element of that. So there's other lean tools and techniques. There's lots of stuff going on here. One of the things they talk about is the waste. So we talk about how we take the waste out. We focus on the waste. We want the waste out of the system, but their waste comes in lots of different shapes and forms, right? So when we think of waste, we think usually first of time, labor, and material. But we'll look at some other waste because they identify 8 main wastes that lean attacks. So we're looking at waste in terms of any effort or expense that's expended that doesn't actually transform the raw material into the item or product that somebody is willing to pay for, that there's a customer willing to pay for. So originally in the Toyota production system, there were 7 forms of waste, but the 8th was added when it was adopted more prominently throughout the Western world and the Western cultures. And we'll look at those one at a time. So the first one is defects. That makes sense, right? You got bad parts, you got something that doesn't work, something that doesn't fit. If it's a defective part, that's pretty easy. But defects are not just these parts. They can be poor or missing documentation. They can be lack of process controls or poor process controls. They can also be improperly maintained tools and machinery. Errors that can be made, like errors in inventory balances or errors in financial accounting processes. So all of that is considered defects. And then excess processing. And excess processing is typically a sign of a poorly designed process. And it can include management issues like lack of communication, redundancies in processes, that you put too many just in case things. If you duplicate the data, or you have to duplicate the data in order to make a decision or move forward. If you are able to use incorrect tools, if you have poor layouts, or you're not using tools the way they were designed, then all of that can be considered excess processing. It takes more effort to make that than it should. The third waste is overproduction. So when, again, I grew up as an industrial engineer, which is all about productivity, right? So we like large volumes, large lots. We like low setups or no setups, reduced setups. So we want to set that process up and run it and run it and run it. But in lean, that says you may be producing too much. So in lean, actually, the optimal lot size is 1, that everything gets produced 1 at a time. Now, that doesn't always fit nicely when you have long setup times, but it says ideally that's what you would do, and you would not have to produce 10 or a dozen or 1,000 of those just because you did the setup. You really want to say, what do I need? So you're not producing one single item over and above the actual demand. When you produce in standard lot sizes, that can be very efficient and productive depending on how you measure it, but it's often not lean. Even though it's a good way to try to increase your equipment utilization, keep people busy, what you might do is make more than you need, and it's going to increase inventory in another part of the supply chain. So you weren't looking at lot or batch production that can also mask defects that show up a lot quicker if you have your lot sizes matching your demand. For example, if you need 80, but your lot size is 100 and you make the 100, but you have some defects in there, you have some scrap and things like that, then you made 100. So it doesn't matter if you lose 2 or 3 or 5 or even 10, because that lot size covers up the fact that you need 80, you have 20 extra, so you can afford to lose a few and you can still make the order and nobody's the wiser. That doesn't really get highlighted. If you need 80 and you start 80 through your process, and at the end you only have 79 or 78, then there's a big flag that says something happened and we weren't able to complete the actual lot. So it's not necessarily for the first time through that you do that, but once you have a production process, you should be able to start with your kit, start in that production line what you expect to get out at the end. So you're sizing that to what you need, and that's not covering up any errors or any problems you have. Unless you have really continuous and stable demand, large lot production can fly in the face of the lean techniques. Then waiting and wait times, these are not good. It doesn't mean that everything moves 100% of the time and it never waits, but excessive wait time, idle equipment can be a waste, and it can also apply to people. However, again, balancing that overproduction with the wait times, you may have people that don't exactly have 100% of their time allocated because you're not producing to the maximum level. So then you have to balance those two things out. Waiting costs the company money in terms of direct labor, overheads. It also includes things like when you have to pay overtime or work overtime, if you have to expedite the labor, time, materials, all of that kind of thing. So when you're starting and stopping jobs and you don't have a nice smooth flow to the material, again, it doesn't mean that it goes automatically from start to the finished goods line without ever stopping, but it means that you have planned and you have small amounts of wait time that's going to help you use your capacity and your capabilities more efficiently. So you're looking at how you can affect that and how you can make that happen through whatever your process is. Inventory is considered it's definitely a necessity, but it's also can be considered a waste. And the waste is due to the cost of handling, holding, excessive handling or holding of that, which can encompass receiving multiple transactions into and out of warehouses, extra security, insurance, and floor space for warehousing, all that kind of thing. So if you can put things out on the floor in bins, then you don't have to transact it into inventory, transact it out of inventory. You can just bring it into the factory, put it right on the floor, and there it's available. If it's something that's expensive, maybe gold-plated leads or something, you don't necessarily want to do that. But if it's nuts and bolts and screws, that's an easy thing to do. So inventory is not entirely a waste, obviously, because we need those products. We need the raw materials to produce the goods. And the work in process inventory represents what is on order or soon to be produced that's going to eventually and quickly, hopefully, produce revenue. But excessive inventories, a lot of safety stock and long transportation times can qualify as a waste. And those are things that you want to identify and then work to remove those from your system. Transportation and motion are very much alike. That's moving material in and around the factory floor, transportation, as well as the freight. Motion is not only the goods that are moved, but sometimes it's the people, and it goes to things like ergonomics. So if you have a workstation where people are having to bend over frequently or to turn around and get something and turn back around and do things that way, that is not ergonomic, and that's motions that you don't need to waste. So then you want to try to redesign your workstation so that you're not moving the people around, the materials too much, or the equipment that you have, because moving equipment too can also be a waste and expensive. And then finally, the last one, the eighth one that was added is underused talent. So the premise is that you want to use the full potential of all employees. So you don't want people who are overqualified doing jobs that don't allow them to use that potential, because it can be demotivating. It can be a waste of money. You might be paying somebody a lot more money that's doing a more mundane task where you're not getting the value out of that. but it's also applied to workers that are performing work maybe without the proper training or without the processes documented in effect so that they can ensure the consistency. So that underused talent may mean that you're not using all of the tools that you have, whether they're people or other processes. The final lesson on lean that I'm going to share with you involves these 5 principles. Some of these may be familiar, but I'm going to try to address those in lean terminology. The first is value, and companies always talk about value, value add, what you're trying to do, what's important to us. So that value in lean is defined as the customer needs for the product and service. So what is going to add value to the customer or to the customer experience? And that's what we want for the value. The next step there is value stream mapping, and that's really mapping the process. It's really looking at once you define the value, how you're going to define the value, then you want to look at what's upstream and what's downstream from that process and those steps that actually produce that value. So you want to map that out from start to finish. And oftentimes this is an eye-opening exercise, as it really documents all the steps that it takes to get from point A to point B. And it can expose waste in a lot of different forms, in the form of like non-value added activity, like repeated inspections. Inspections are not really adding value, they're just checking things. So that can be considered a waste. If you're doing a lot of transferring, a lot of movement, a lot of the things we just looked at, overproducing or too much inventory, those things, the value stream mapping can help identify those. It's also a process that goes further to really what we call re-engineering. When you're starting from a clean slate and saying, if I was going to make this, or if I was going to do this process, what would I do? The re-engineering is really not trying to tweak it, but it's really taking a clean piece of paper and saying, this is my task, this is my objective to get from here to here. So what's the best way to do that? And then you look at that ideal process, the newly created one, with what's existing, and then you look to see where they differ, where they're alike, and what you can do to improve that. You might not be able to get completely to the ideal redesign state, but you can make some significant improvements. And then once you get the waste from the value stream taken away, then the process should be reviewed again. You're looking for disruptions, you're looking for interruptions in the process, bottlenecks. These can all reduce your cycle times. And when you fix those, you get benefits in productivity and efficiency. And they say sometimes you can get as much as 50% higher efficiency or productivity. And I've seen numbers that really approach that in my own places I've working with different processes, trying to get those streamlined. The next principle really is pulling instead of pushing. And when you look at the demand patterns of pull versus push, push says, I'm going to make whatever's on my production plan. I've got a forecast. I'm going to make to that. And I'm just going to make things until somebody tells me to stop. Pull says, I'm going to wait till I have a more clear signal, either a customer order or maybe a revised forecast or an approved forecast from somebody that takes into account the backlog, the orders, and the latest we have from our customers. So then you're waiting until you get that signal that's pulling, and that tells you to produce that. So and a lot of organizations have what we call a push-pull boundary established, where you have some materials that are purchased in anticipation because you know what you're going to build, you know what your product offering is. But actual production isn't scheduled until you have orders or till you have another signal for demand, like maybe a Kanban. For example, if you think about a bakery always has on hand butter, sugar, flour, eggs, all that kind of stuff. They have vanilla, they have their chocolate stuff, they have all of those kinds of things. But sometimes they don't start producing everything until either the inventory dwindles down to just a couple, or when they get a specific order for something. So you think about cakes, they may make certain cakes and have yellow cake, white cake, chocolate cake, and they may keep them uniced. So they wait to see what's being sold, or they may have a standard offering, but they keep other cakes behind in the back, so that if you come in and order something, or oftentimes you'll see where they put white frosting on it. So whether that's buttercream or whatever, it's a standard white cake frosting. And then you come in and say, you know, I need a birthday cake for my mother. So can you put some roses on it and make it say happy birthday, mom? Or maybe this week it's happy Mother's Day, mom. So you can write all those things on it and customize it. It doesn't mean that they have nothing done, but they're not going to make all of that. And then the pure pull signal is something like a wedding cake. You don't make a wedding cake in a bakery until you actually have an order. Now, again, you still have butter and sugar and flour and all the things you need to make that cake, but you don't start producing that wedding cake until you know that the wedding is on Sunday and you're going to start on Friday making that for whatever customer that is to that customer configuration. So the pull to the extremes, and then the push is just, we're going to make cookies and we're going to make 6 dozen chocolate chip cookies every day. And then I'm going to check and see what I have at the end of the day. If I have a couple left, then I'll make 6 dozen the next day. If I run out, I might make a few more. And if I have a dozen or more left, then I'll cut that back. So the different push versus pull, and lean is very much the pull system, responding to your demand signals. And then finally, the principle that is there is perfection. And this is really about acknowledging that lean is this iterative process. It means you've got vigilance and continued efforts from the entire organization to make it successful. And lean experts say that the process isn't truly lean until it's been value mapped at least a half a dozen times. So this is very much a process. So when you get finished, traits of lean organizations include things like accountability. People are readily accountable for what they're supposed to do. And you have this, you see this in things like daily stand-up meetings or team huddles that people get together on a regular basis and review what they're going to do. It's not long drawn out meetings, but it's very focused. These are the tasks. We review that. You're going to do this. I'm going to do this. We've got the accountability in. It's seen by an organization that has leaders that are doing what they say they're going to do. They practice what they preach. It's a very respectful organization where there's a lot of teamwork. There's a lot of cross training, those kinds of things. Very adaptive. So change is readily accepted. And people self-correct on the course. So they, if through the course of the day, if they see something, they're empowered and they're motivated to make those corrections and do that course correction without a manager specifically asking for it, directing it, or whatever. It's a safe space, like I talked about before, where you have this honest, candid discussion about things, and then you're really able to balance the tactical and the strategic, and everybody understands the alignment. So that's lean. So I'm going to spend a few minutes talking about Six Sigma. And Six Sigma is really heavy in statistics. So it can really get your eyes to glaze over. So please bear with me for a little bit. I won't go too much into the statistics, I promise. So it usually assumes a normal distribution. And if you're not familiar with that, that's what most things in the world fall to. There are other distributions, but a lot of things fall into normal distributions. And that's that kind of curve that looks like this. So you have this normal where you have balanced on both sides of the average or whatever. So that's Six Sigma actually refers to 6 standard deviations, and that means 6 standard deviations on either side of the mean. And it equates again to 3.4 defects per million opportunities. So using Six Sigma, it's a disciplined approach, it's data-driven. It's a methodology that you use, and there's 2 ways to do that, and I'll talk about those in a second. Here's some statistical terms that you might want to be familiar with. First is a mean or average, which most people are familiar with. Then there's this standard deviation, or the sigma part of Six Sigma. This is the extent of the deviation, how much dispersion there is, how far that is. So in a sample of a lot size, how much difference do you have, inconsistencies from one to the other? Then the range is the difference between the highest and the lowest value within that sample. So if you're measuring weight of M&Ms, it would be the one that weighs the most minus the one that weighs the least, and that is going to give you your range. If you're measuring table legs, it's going to be, and they're all supposed to be, 36 inches or 30 inches, 30.0. If you have some that are 30.1, 30.2, and then something that's maybe 29.8 8, then you take the range of that. The sample size is how many data points you use to ascertain the goodness of the entire lot. So if you're making 1,000 of something, you don't really want to check every one 100%. You want, if you have good processes, you should be able to do a sampling of that 1,000-piece lot and say, yes, this looks good. It looks like everything is consistent. And then you have confidence levels, which give you the surety of the results of your test. So if you take a 30-piece sample size from the 1,000 pieces that you built, and you follow the ASQ guidelines that say this is how many are acceptable, then that gives you a confidence level. Confidence levels can go very, very finite. You can have confidence levels as low as 80%, 90%, and then you can get up to 99 and even more. So you have to look at what is desirable for the things that you're doing and measuring. And then the higher the confidence level you require, again, the more stringent the acceptance criteria from that lot that you're sampling. So there, I'll give you an example. You could have a lot size of 400 and you pull 20 to be tested. If 2 or more or 2 or less of those are defective, then you can accept the batch with reasonable confidence. If 3 or more are defective, that says, hey, you've got a problem here. You don't have consistency in this lot. So then you reject the lot or put it on hold, and that requires 100% inspection of everything that's in there to say, are these really good or not? So you want to look at what that means. And then if you need a 99% confidence level, you may only be able to reject 1 in that kind of lot size, and it may be a bigger sample size. But there's lots of tables that you can look at that have developed that statistically for you. Or find your friendly neighborhood ASQ person and they can help you with that well, or your quality person. There are 2 kinds of data, variable and attribute. Variable is quantitative, things that we measure like weights and lengths and dimensions, elapsed time, maybe thickness, it can be pressure, all that kind of thing. And then attribute data is what's qualitative. That's more of the pass fail, the good, bad, and those things. And then the control charts are the way we graph those. So this is, again, the normal curve. And you can see if you're the green curve, the one on the left, is a lot higher and narrower. That means you've got a smaller range of variation in there because the distance between the 2 green lines is narrower than the blue line. The blue line still indicates a normal distribution, but it says you've got a wider dispersion of variation. So you've got just more things and a broader range of what you're seeing in your results. If you look at Six Sigma, generally the standard deviations are, you can go 3 standard deviations on either side, which is really not the Six Sigma, but if you within 1 standard deviation on each side, you get about 68% of the population of the data that you have. Within 2 standard deviations, you're going to get 95% of the data. Within 3 standard deviations, again, on either side, you're going to get 99.7, but 99.7 still isn't 3.4 defects per million. To get that, you have to be out in the 6 sigma range. So you can see, though, that with the 3 sigma quality, you're still hitting 99.7% of your data points within your curve, which is a good thing. Now, what you want to do is make sure that your specification limits are outside of what your curve is telling you. In this case, your curve is here, your specification limits are way wider than that, so you've got no problem. There's a lot of different things about control and migrating. This is just another way to look at that same chart with the, and this one's kind of blurry, so we'll skip it. You can chart things. The variable data is usually with X-bar and R charts. X-bar charts are the mean. So you look at, this is your average number here, and you can see in this case, it's 155.561. And you can plot in this case, it's different lots and it's around that. So they're all going to vary around that mean. In this case, you calculate statistically upper and lower control limits that say, my variation is between these 2 lines. Now, this is not necessarily your specification line, so you want to make sure your control limits are inside your specification limits. that doesn't always happen. But the range tells you something different. The range, again, is the difference between the high and the low value of the sample size within these lots. So in this case, you can see that this is the average here is going to be 2.2, which this X bar for this strength is 155, but the range is 2.2. So depending on what your specification limits are, that's telling you how you're working in there. And you could see that sometimes the range limits will go in an upward direction and yet your X bar looks fine. So that just tells you that there's different things going on. And usually companies want to use both of these because they give you a little bit different insight of things. If you see the R bar growing, what happens is you're going from a nice tight version of this, to more spread out. This is an increasing R value. If you have a decreasing R value, it means you're pulling that in and you're going more to the green line. So that's an important differentiation. And then if you have attribute data, like you're looking at scratches maybe, or defects in terms of visual anomalies, maybe a paint drip, a scratch, a chip, then you count those and then you can plot those this way. There's called a P chart and a C chart. The C chart is the count of how many defects you have. And usually you look at that by different types. And then the P chart is the proportion or the percentage. So the C is count, the P is percents, and that's how you calculate those. To use Six Sigma, you use this DMAIC model. At the heart really is the DMAIC model. It's not finding a solution in the define process. The define is really determining what is the real problem. You're trying to get to the heart of the problem, not the solution, but you're finding out what's not working, what's broken, whatever, trying to identify an area that you want to put an improvement project in place on. Then you measure and you look at the value streams. You do the value stream mapping. You look at any process documentation you have, looking at what should be going on, what actually is going on, and then making improvements from there. You take all the data you need in this measuring phase. If you have the ability, you can look at process capability, CPK. If you know anything about SPC, you can determine that. And you use Pareto charts, like I said, to look at the defects and measure and look at what's the most important or what's the most common. Then you go into the analyze phase. You're looking for the root cause in this area, which means you're really digging into the problem and not necessarily going up far afield from the way it was defined. If you did the work up front defining the problem well, then your analyze is going to be an easier step to take. So this is where you do things like the FMEA, which is failure mode and effects analysis. This is where you do some of the other statistical analysis. Then you go to the improve, where you can do your design of experiments. You can do Taguchi experiments, which look at how the different variables relate to each other. Because when you make a process improvement, what you want to do is improve the overall process. You don't want to make a change over here and then find out that you blew something up in another part of the process. So you want to make sure that you're looking at the effects of that all the way up and down that line through that value stream map. And then finally, you need to put some controls in place. You want to put some quality plans, use your SPC techniques, verify the results that you expected. Back in the improve, you might have done a pilot project or a prototype just to see, do we think this is going to work? And is it going to give us the results we desire? And then you're able to do that. You put the controls in place and then you go, again, it's a circle. It kind of starts all over again. Another model is the DMAVD, which the first three steps are the same. And then instead of improve, they use design. And then instead of control, they use verify. So both models are the same. Whichever works for you is applicable. Some other tools that are used, there's things like the 5 whys, which you ask over why is this a problem? Well, this we're not getting the yield that we need to get. Okay, why are we not getting that? Well, because we're losing We have too much scrap. Why do we have scrap? Well, the parts don't fit in this station. Why don't they fit in that station? Because we changed vendors and we've got another vendor. So you keep digging into that with these 5 layers of why to figure out what happened or what might happen and how you might fix that. Just in time, another concept with inventories, minimizes inventories, looks at pull systems. You have your Plan, Do, Check, Act, Plan, Do, Study, Act, PDCA, PDSA. You might be familiar with those, pretty common tools. Kanbans we talked about. Check sheets are pretty easy when you just count how many parts that you have scratches or defects or whatever. And then you look for the bottlenecks. So these are all tools that go in Six Sigma. There's different certifications and different roles in Lean and Six Sigma. The basic one is a yellow or a white belt. These are not as prevalent in classes that you can take. They're usually in-company programs that are designed for a certain company, a certain set of processes that are used, and you get that belt in from your company. Green belts, you need to be familiar with the DMAIC process. You have to take some tests. You have a project completion. I happen to have a green belt. I got it through the University of Michigan. It was sponsored by the company I was working for, but I had to take all of the courses. I don't remember how many there were. There were different sections. I had to do that. Did that through the University of Michigan, did a project at my workspace, submitted the project and got my green belt certificate. No certification renewals, no continuing education credits or whatever you call those required for those. So those are good things to get. Once you get it, it's good for life. Black belts, master black belts. Black belts are the project leads. It's harder to get that. It's a lot more statistical testing and knowledge that's required for that. These are the project managers. So if maybe some of you guys have black belts, these are the people that lead these projects, that manage the people that lead these projects. And the master black belts are usually over several other black belts, either based on a product line or a division or whatever. And then you have champions. These are the people that say, hey, we need a black belt project over here, or we need a Six Sigma project, or let's do a lean Kaizen for this area. These are the people that look at the companies. These are usually higher level managers, directors and above. They have the ability to translate the company's vision, mission, goals into these projects that are going to be undertaken by the organization. They make sure you have the right resources. They give you budget for people and for whatever kinds of tools you might need. And they are also challenged with removing obstacles as the project goes on. So many lean projects are shorter and quicker, less intensive, but they still require people to get them done. Some of the black belt projects can be very long and very, very big projects that have project managers, such as a lot of you, working on those. And maybe they're working alongside a black belt, or maybe that in addition to that, they also have the black belt. But the champions are the ones that remove the obstacles and make sure that you stay on track. And that's who your project manager is working with very closely and staying aligned with and making reports to. So what I know for sure is there's a better way to use Lean and Six Sigma philosophies, and they can be used in any and every business. One of the first things companies see when they start implementing these methodologies is improvements in employee morale. This is a really important aspect of that. Lean and Six Sigma, again, rely on these subject matter experts, which are the people that are actually doing the work, and they ask for their opinions, they ask for their insights. They're the ones coming up with the solutions because they actually know what they're doing. They're the subject matter experts. Their knowledge and their insights are really key to making the changes and improvements that are going to help the business, but they're also key to making sure that they stick, that these are the changes that are made are actually incorporated and used by everybody. If we get out of the box and look at the operations and the tasks and the project plans from womb to tomb, we really want to look at it again from the customer perspective. When we do that, what we find and what companies find is their customer satisfaction scores go up, their complaints go down, their returns, their all of that, all of those warranty issues go down, and their later on repair issues go down. That saves the company money. So when you look at it from a customer perspective, you're going to get better results. basically it's math, right? Revenue minus expenses equals profits. And if you reduce the waste, that reduces the cost, both indirect and direct costs. So profitability is going to improve. And sometimes you get the quality to a level where you can actually increase your price and do even more for your profit margins. So there's a lot of opportunities here. Lean and Six Sigma cultures really support job growth. They support cross training of organizations, more empowerment. They help companies scale. They help them reduce their inventories. They help them improve their utilization. The whole company culture will change with enough time and enough effort put into both the Lean and the Six Sigma. And one statistic said that black belts generate savings of about $250,000 a year, and they make about $80,000 a year. So you're getting a 2-to-1 return on that salary. They're paying for themselves, plus they're saving you another $170,000 or so. So $150,000, I guess, is the math. So it's a good investment. So if you know this, or hopefully this has given you some of the basics. And I know that this is a lot to digest in an hour or maybe just a few minutes more. So usually I'd like to talk about this, but it's hard on Zoom and most of you don't have your cameras on. Like I say, I know this Zoom overload is all out there, but I want you to, hopefully you have a better understanding of what your organization can do. This says, or understand your organization's understanding. That was a bad sentence, but you want to start with these lean concepts, because getting rid of the waste, everybody can find waste somewhere. There's always, it's easy to spot and say, oh yeah, this is driving me crazy. This is the waste area. And then keep in mind that continuous improvement is this journey. It's not really a destination. So if you're ready to implement this, if you feel pain from this, if you want to take some action, if you want to make a small investment to help identify opportunities, get some tools in place, think about what you have at your disposal in your work. And if you'd like to work with somebody on that, you can work with my company, several others. If you'd like to talk about opportunities, you can do this call with Jane. Callwithjane.com will take you directly to my calendar. You can book a free call with me, free half-hour call to talk about whatever you want related to supply chain or Lean and Six Sigma techniques and processes. So I told you I'm going to give away some gifts. So if you want to do a call, you can schedule that, and you can do that call with Jane. You can do it now. You can do it tomorrow. And I always encourage you to do it now before you go back to your desk tomorrow or tonight or in the morning and see, oh my God, this is the crisis of the day. So you can do that. And if you want to participate in the webinars, you're going to have to send me an email. And I've seen quite a few of those come through, which is good. But if you book a call, you're going to get the slides from the presentation and a subscription to my webinars. I do webinars for supply chain on the 2nd and the 4th Tuesdays of the month, and they're recorded, they're online. If you can't make them, I give you the recording and I give you the slides, and I have a whole bank of those if anybody's interested in those. So now this is your last chance. If you would like to be part of this raffle, here's what you're going to get. You're going to get the slides. So if you want the slides that I have here, you're going to have to send me an email, because I have no other way to get you this information. So you need to send me an email to jane@purplelink.co. Just put webinar in the subject or whatever, because I've got pretty much all of that here. You're going to get the slides, so you'll get that. And then the winner, everybody that sends me an email will get the slides. So I'll send that out tomorrow. The winner of tonight will get the slides. That they're going to get this book, which I think is a great book. And it's really applicable to Lean and Six Sigma, because we talk about KPIs and things like that. But in this book, Measure What Matters, he talks about OKRs, objectives and key results. John Doerr worked with, it has a foreword by Larry Page from Oracle. I think it's Oracle. He worked with Google, Bono. He's worked with the Gates Foundation, Rock the World, a lot of these different companies. And Intel was a big proponent of this. And he got a lot of his information from Intel, working with the CEO of Intel. So It's a good book. It's a great book. You're going to get the book, and then you'll get a subscription to the webinars. So anybody who wants that, I'm going to give you about 30 more seconds as I count up and see and use my fancy random number generator here. Okay, so there's my random number. Let me see who that is. It's Ed Stegman. Are you here still, Ed?
Yeah.
Okay, good. So I'm going to ask you, Ed, to send me one more email that has an address where I can ship your book.
Okay.
So just tell me where you want me to send that. And again, all of you, thank you. I will send out the slides tomorrow to everybody whose email that I have. If you'd like a subscription to my webinar, just let me know. I'll put your contact information in there, and you can sign up for the webinars through one of those informational mailings that you get. And I'm right now happy to take questions, answer anything that I can answer, take comments.
James, this is James. First off, I'd like to thank